Okay, distance between 2 points. So I want you to plot 2, 3, and 6, 3 and connect them with a line segment. Remember, first is your x, second is your y. You forget alphabetical order. X comes before y in the alphabet. So the first is the x, the second is the y. Plot those. If you need a straight edge, then if you have an calculator that has a battery pack in it, as opposed to plugging in, there's your straight edge. Okay? If not, invest in a ruler. They're about a quarter at the dollar store. 4 for $1. I have 5 for $1. Okay, be quiet, please. Quickly. Plot them, join them up. Okay, so notice that they form a horizontal line. Oh, label the points. Sorry. So that's 2, 3, 6, 3. So it says what kind of line segment is this? It's a horizontal line segment. Sometimes students get mixed up between horizontal and vertical. Think of the horizon. The horizon goes this way, right? Parallel to the ground, not vertically. So that's horizontal. When it's true of the coordinates of the points on the same horizontal axis, take a look. What's the same? The y values are the same. So here, the y coordinates are equal. Or same. So anytime you have any set of points where they have the same y value, those points are all going to lie on a horizontal line. Okay, I don't know who's mumbling away. Okay, what is the distance between these 2 points? Well, you can just count it up because we graphed it. So 1, 2, 3, 4. You're counting the spaces, not the dots. So 1, 2, 3, 4 is the distance between them, 4 units. How can you determine that by using the coordinates? Well, take a look at the x values, 6 and 2. How do you get 4? You subtract them. Okay, so 6 minus 2 is 4. Okay, so now use your rule to determine the distance between these 2 points. It's always a positive number. So here, your y values are the same. We want to subtract those. It's a positive. So I'm going to take, it needs to be a positive when we're talking about distance. So I'm going to take the biggest x value and subtract the smallest. Now, if you took the smaller and subtracted the larger, you get -6. What you can then do is take the absolute value. We haven't talked a lot about that yet. We will as we go on. Absolute value of negative gives you a positive. But for right now, I would just choose the larger x value and subtract the smaller. Then you're guaranteed you don't have to do anything else. Verify your answer by plotting the points on the above grid and determining the distance by looking at them on the grid. So -4, 5, and 2, 5. -4, 5, and 2, 5. Okay. Okay, and then if you count up, so 1, 2, 3, 4, 5, 6. Okay, again, counting the spaces. All right, general case here. We've got 2 points on the same horizontal line, so you can see the y values are the same. They're both y. The x values are different. So for coordinates, we often use subscripts like this to identify a different x value in this one than in this one. So this would, like with ones, we call that the first point, and this would be the second point. So write an expression for the distance between, so I subtract the x's. Doesn't matter, you don't know which one is bigger, but since 2 is bigger than 1, I'd probably go x2 minus x1. Okay. Now, that's where if x2 was the smaller one, then you would need an absolute value. But we'll just leave it like that. We're going to see in the formula that we don't even need absolute values at all. Okay. So next one, plot those points, -3, 1 and -3, 6. Draw a line between them. What kind of line is that? Vertical, exactly. So when you have points on the same vertical line, then their x values are the same. Or x coordinates, I should say, I guess. So what's the distance? Count the number of sides of the squares. So 1, 2, 3, 4, 5. Okay, and then from the coordinates, well, we would subtract the y values. So that's going to be, the largest one is 6 minus the smaller. So 6 minus 1 equals 5. So if we have the x values the same, then we're going to subtract the y values. Okay. Larger minus the smaller, that would be 5 minus -2, which is 7. Okay. Obviously, if you graph them, you can count it up. If you went the smaller, -2 minus 5, you get -7. Can't have a negative distance, right? That's where you need absolute values if we were just doing that separately. But we'll see that we don't even need absolute values what we're leading up to. Okay, so plot them and determine the distance using the graph. So that was 5, -2, and 5, 5. Oh, there's not quite enough space here on the graph, but it's pretty close. We can get close enough. Okay, and then counting 1, 2, 3, 4, 5, 6, 7. It's amazing how many times I get people counting the dots, not the lengths of each side. Okay, and then here, now if we have the x is the same, we're going to subtract the y's. Okay, and again, I'm going to go y2 minus y1. The second point minus the first one. We don't know what the values are there, but that's going to be, that will work. You may have to make it positive if it's negative. Okay, so this is going to lead us into the next part where we have what we call an oblique line. Okay, so this is going to be diagonal. How are we going to get the length of it? So I want you to plot those 2 points, connect them with a line segment. Okay, and then how do we figure out the distance between them? And there's a hint. Draw a right triangle with that line segment as the hypotenuse. That's going to help you out. Okay, so start plotting and graphing right now. So the proper math word is oblique. Okay, you might say diagonal. Okay, but that's the math word. I guess I should label these 2, 3, and 5, 7. Okay, what's the distance between the points? So the hint, draw a right triangle with the line segment as the hypotenuse. So you can either draw the right triangle this way or this way. Really, it doesn't matter, right? So either way, or you can go above, draw it that way. Okay. So I'm just going to minimize this here. Okay. So what's the distance between them? Well, take a look here. Look at it. Pythagorean theorem needs the lengths of these 2 sides. So that's 3 units. 1, 2, 3, 4 units. So often we call the hypotenuse c. So c squared equals 3 squared plus 4 squared. Works out nicely in this case, because that's 9 plus 16 is 25. So c equals 5. Remember how we talked about when we have c squared equals a number? It could be positive or negative, right? But in this case, we're just choosing the positive, because we know we can't have a negative length, okay? So that's why we don't show the plus or minus in this one. Okay, we don't know if it's centimeters, so we'll just leave it. No units there. How could you use the coordinates of the points to determine the length of the horizontal segment? So the horizontal, well, we get 3 by looking at it, but really that's 5 minus 2. Okay, so 5 minus 2, so horizontal equals 3. And the vertical, that's 7 here minus 3, okay? So those are the coordinates, the y's. Okay, so basically we don't need to graph it in order to see what those distances are. We're taking between these 2 points, the distance between these, so 5 minus 2 is 3, putting it into Pythagorean theorem. 7 minus 3 is 4, putting it into Pythagorean theorem. You don't even need a diagram. Okay, use your rule to determine the distance between these. It's always a positive. So c squared equals, and so that's where with your x's, we go, so in this case, 7 minus negative 5, and we square it. So we're finding the distance between the x's and squaring in the Pythagorean theorem, plus distance between the y's and squaring, it's the vertical, then figuring that out, so that's 12 squared plus 5 squared. Plus 25. So C equals the root of 169, which is 13. Okay. So really, we're wanting to find C. What we need to do is take the root of this whole thing. That would be sort of your one step. And that's where the formula comes from. So now we're going to try to come up with the formula here in our general points. So the length of the horizontal would be x2 minus x1. Again, I'm going with the bigger subscript. We don't know what the values are. Notice how it doesn't matter if we get a negative for either of these because we're squaring them. And a negative squared always gives you a positive. So that's why we don't need absolute value signs. So now I'm going to call it D for distance, or write the word. It's going to be the root of the Pythagorean theorem. X2 minus x1 squared plus y2 minus y1 squared. Okay. That's the formula. Do you have to memorize it? Not really. We'll give it to you. But it's certainly a really good idea if you can. Okay. Let's look at some examples. So determine the distance between the 2 points shown on the grid to the right. Now, if they're on a grid, you don't have to use the formula. You could draw a right triangle and count them up. Yes? I can't hear you. No. You have your marks, but you're not your teams. There's still people that have to write from last week. So, you can join those up. Okay. Then, from there, you can form a right triangle. Okay, so there, you can count 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. You can tell me what the hypotenuse is without doing any calculations. 10. How do you know that?
3 and 4 and 5, 7, 6.
Right. What do we call those three numbers that kind of satisfy the Pythagorean theorem like that? Often they're called a Pythagorean triple. So it might be just three numbers. They might not be from a triangle. But a Pythagorean triple are three numbers that satisfy the Pythagorean theorem. So 3, 4, and 5 do. Any multiples of it. So 6, 8, and this would be 10. Okay? But how do you get that if you weren't sure? Then Pythagorean theorem, c squared. And you can really go c equals now the root of 36 plus 64, which is 10. So I didn't do the subtracting of the coordinates because they didn't ask me for a certain method. It just said determine. Determine means show your work, and I did. Okay. But the next one, we will then use the formula for, because we don't have a diagram. Okay, so the next one says the vertices of a triangle, they're given. Is the triangle scalene, isosceles, or equilateral? Provide evidence to support it. Who can tell me what an equilateral triangle is? Hands up. No.
Or all sides.
Yes. All sides and angles are equal measure. So we need to find the distance between each of these pairs of points. What about isosceles? What does that mean? Thomas? Two sides and then obviously two angles as well.
Yeah.
And scaling, they're all different. Okay, so we are going to calculate. So here, you might want to call it D, the distance of AB. Now, A to B. So I'm just going to go, B is my second point, A is my first point. So -5 minus 3, all squared. Remember, it doesn't matter if you get a negative, because when you square it, you'll get a positive. You get a negative when you square it, you give me another gray hair, right? Because a negative squared is a positive. And then the y's, -4 minus -2. So that's -8 squared plus -2 squared. Okay, you can do some of this work in your head or calculator. So this is going to be 64 plus 4. So that's going to be root of 68. Okay, and then should reduce it if you can. So does 4 go into that? Yeah, it does. So it's going to be 2 root 4 goes into that once 7, right? Yeah. Okay. Now find the distance of BC. If it says show your work, it's a written response. I'm going to want to see the numbers substituted before you do any subtracting. And then you can go from there to there and simplify it if you want. But I need to see what you're substituting in. Especially if you make a mistake, you won't get any part marks if you don't show it. So we've got two sides are different. Okay, so it could be now or no, it's not equilateral. It could be scaling or isosceles. You still need to check the third side. So we've done AB, BC, so now we need AC. Okay, even if you can tell it's not going to be the same, because this you see a 6 and a -2, 8 and -2, -2 and 4, still complete. Okay, show me the simplified form of the length of each side. Don't just say, oh, they're not the same. I want to see a full, proper solution. So that's going to be 4 plus 16 is 20, which is 2 root 10. Okay. So now you want a statement answer. The triangle is scaling as the lengths of the sides are all different. What's up? Did I do something wrong?
2 and 5.
Oh, yeah, it's 2 and 5. Thank you. Sorry. 4 times 5 is 20. Yeah, stop touching each other. Exactly. Leave each other alone. Hey, turn around and talk. He's not touching you right now, so you're good. Okay, so now determine the perimeter. Express your answer as an exact value and round it to the nearest hundredth. So the perimeter, we have to add up all the sides, right? So that's why having these simplified is helpful, because we know now that we can't collect any like terms. Okay. So that's the exact value. To get the decimal form, 2 root 17 plus 2 root 10. Make sure to cursor out of your radical, plus 2 root 5 if you have a newer version of the calculator. So 19.04. Okay, we don't know what units it is, so we'll just leave it. Yes, honey. I can't hear you. Fraction? I don't know how. You're irrational, so you can't. It'll be rounded. Okay. So now, is their triangle a right triangle? So we're going to take the sides, and if it's a right triangle, it's going to satisfy the Pythagorean theorem, right? So we already have all the distances, so that's good. I would actually look back to the unsimplified form, right? So these, you can tell which is the biggest. It's root 68. So with my Pythagorean theorem, so when I prove something, okay, I like to use what I call a T-chart if I'm showing if something is verifying an equation or formula. So the left side of this equation is my hypotenuse, which is going to be root 68, and I'm going to square it. And I want to see if that's equal to the right side, which in this case, it doesn't matter which order, but I'd have root 40, this up here, root 40 squared plus root 20 squared. So you can see here now that that's going to be 68. This is going to be 40 plus 20. So they're close. Oh, what am I doing? They're close, but they're not exactly the same. Okay? So this left side of the equation is not equal to the right side. Okay? So you're just checking. If you were for sure it wouldn't work if you put in like root 20 on the left. So you want to make sure though that when you're checking it, you're choosing the longest side to go into for the hypotenuse. Otherwise, for sure, it's not going to work. Okay? All right, and then example 3, the diameter of a circle has n points given to you. So we've got a circle here. So this might be negative 6, 3. This might be negative 10, negative 5. Okay? and you're asked to determine the exact value of the radius. Okay, so yeah, you could find the midpoint. We'll talk about that tomorrow. But for right now, we know the radius is half the diameter. So radius is diameter divided by 2. So let's find the diameter. Turns out diameter is the distance between those 2 points. So this D is like distance as well in this case. So D will be, so the difference of the x's squared plus the difference in the y's. Okay. So simplify those. So negative 6 plus 10 is 4. 3 minus negative 5 is 8. You want to do that all in one step. So 4 squared plus 8 squared. That's 64 plus 16. So what's that? 70, 80. Then simplify root 80. 80 is what? 16 times 5. So that's going to be 4 root 5. So that's the diameter. Therefore, the radius is 4 root 5 divided by 2, which is 2 root 5. Okay, so that is distance between 2 points. All right, and you can see the next page, there are exercises and the answers are at the end. So as well, there are questions from the textbook. So both the booklet and the textbook.